This time I have a Sonic Frontiers SFS40. This is a 40 watt per channel vacuum tube amplifier made in Canada around 1992, 93, somewhere in there. And this one's got one channel that's dead. So we're going to get into this one and see if we can figure out what's wrong with it. I've already looked for a schematic. Nah, can't find one. So we're working off the board. Let's check it out. This is a Sonic Frontier SFS40 stereo tube amplifier. Obviously it's tubes. You can see the tubes. Beautiful. I'd love to have one of these. This is a beautiful looking amplifier. No doubt about that. This one channel is dead. His other concern is when he sets up the bias, he says the bias is jumping all over the place. The first thing you notice is it's got a knob on here. This selects the 4 tubes. It's a 5-position switch. And we switch to the dead channel. We see we got 40 milliamps, which is correct. This one here is a little bit lower, but we can adjust it. 40 milliamps. What I've noticed is that the switch itself seems to be problematic. We go to the other side over here, this tube here. We can turn it up to 40. See if it'll stay there. And then finally this other tube. But you see, I think the reason his reading is jumping all over the place is the switch itself has a problem. You see the meter moving around? So this one's all over the map because the switch itself needs to be cleaned. That's not the concern. The concern is that there's no sound. Now we know the outputs are working because we've got bias, so we've got power there. But we have nothing. When I play music, I only have one channel. So, where's the problem on this? Well, we'll first try swapping the preamp tubes around. Shut the power off. This thing's going to take a while for the voltage to drop off and the tubes to cool. But we'll try swapping the preamp tubes around because we may have a bad tube. Probably not, but it won't hurt to try swapping the tubes from one to the other. Now we'll see whether our channel went from one side to the other. That'll rule out the tubes causing a fault. And we still only have one channel working. So we definitely have a fault in the amp. I'm going to shut it off here. I got to let it cool down because the tubes are hot. In order to turn this thing over to remove the bottom, I've got to actually remove these tubes because they are higher than the transformer. So in order to turn it over, just to take the bottom off, I got to remove the tubes so that they don't get damaged. So I'm just going to let them cool down for a bit, and then we'll pop the tubes out and turn this thing over and pull it apart and find out why one channel is not working. Okay, first we'll remove the bottom. I've got the tubes pulled from it now so as to prevent any damage. The unit's sitting on the transformer's end. The corner is sitting on a box here to keep it off the bench. Not that the front will touch the bench anyway because the filter caps would prevent that, but it's not resting on the filter caps, it's resting on a box. There's the internals. First thing I see on this unit is it looks like the caps here have maybe been upgraded. They're Wonder caps. I don't know whether those are what those are. They're made in the UK, so these are probably good caps that are in here. Wonder cap 0.01 microfarad, 630 volts. There's 2 of them in parallel, so it's like 0.02. These are the ones for the right channel, and these are the ones for the left channel. The left channel is the one that is out on here. You'll see it's got solid state rectifiers over here. There's looks like a regulator transistor over there. There's an IC over here too. And there's a couple transistors. There's one transistor here, and there's another transistor over there in the preamp circuit. Wonder why they have transistors in them. On a full tube amplifier, there's a couple transistors in here. There's a big one over here as well. Q2. I probe the amplifier preamp and see where the signal is being lost. So I got my scope probe here. We're going to plug the amp in. When working around vacuum tube sets, remember that the voltage is extremely high. We're talking in the hundreds of volts range. We can check that with the voltmeter right now. I've got the main power output tubes removed, so just the preamp tubes will be lit up here. But if we look at the voltmeter here, we'll see what our voltage is going to be going up to, which is a ridiculous high voltage. 550 volts. So it's a voltage doubler. That one's grounded. Right, there's half the voltage, 275 volts. It'll be 275 volts on the negative. And here's our B plus, 542 volts. So this thing here will kick your ass if you're not careful. And this voltage will appear on the outputs here. Right here's our center tap here. We'll have our full voltage right here coming out of the transformer. Right, and this one here on this side is right here. That's it there. That's going to the output tubes. Right there, and the other one's over here. This is going through the transformer. Our preamp tubes are over here. This is where the voltage goes in. Our signal goes in here, goes through the two preamp tubes, and ends over on the output tubes over here. Our signal should be present on these capacitors here. This is the blocking capacitor. This is the bias voltage, minus 23 volts, minus 25. We should have signal on these capacitors here when the music is playing, which it is now. So I'm going to check it with my meter, my scope. Got my times 10 probe on, and we're just going to check it right down here on the and there's nothing, no signal coming up at all whatsoever. So I didn't expect anything to be there, because we would see it on the actual output tube on the grid, and the output tube would be working if there was voltage, but there's none. We're losing our signal somewhere between here and here in these tubes here. I looked for a schematic, I could not find one for this unit. Therefore, we're going to have to kind of work blind. If I take a look at the input, I believe this is it here. Gotta be really careful when I touch this thing, because there's high voltage everywhere I'm looking. I don't want to get zapped. So gotta be really, really careful when working on a unit like this. One hand in the pocket at all times, or one hand away from whatever you're checking. So I want to see if I've got a signal getting to the unit itself. I don't see any signal. So I'm just doing a comparison between the two of them. I should have audio on pin 1 from my preamp tube here. I have audio on my preamp tube on this side. Pin number 1 over here has got plenty of audio. I'll show you guys the scope. I'm using my digital scope. And pin 1 over here has got nothing. I'll show you the scope just so you can see what I'm seeing. So look at pin 1 for the right channel. Okay, there's our audio. Here's pin 1 for the left channel, the one that's not working. We have no audio. So therefore, the problem is somewhere between the input and this tube here. I'm just going to shut it off, unplug it, and let the caps drain. They do have bleeder resistors on them, so they will discharge on their own over the next couple of minutes. If we watch the voltage here, we're down at 140 volts now, and this one here is down at 206, 250. There is bleeder resistors across the capacitors to drain them down. So we'll just give this a few minutes to completely discharge. And I gotta watch this wire here, because this probe is breaking. I'm gonna have to repair this probe before I get zapped. Guess it's starting to come apart. Or get some new probes. That's an idea, new probes. Well, let it discharge completely, and I'm just gonna take a look and see if we can figure out where we're losing our signal getting into the main tube here itself. The preamp tube, because there's nothing there. I should have actually checked the voltages around the tube first of all, just to make sure it's getting voltage. Maybe we'll do that. Plug it in again, we'll power it up. I'll just do a quick voltage measurement without electrocuting myself here. Pin 1, where I had audio here, we have 130 volts. On this tube over here, pin 1 is only at 14. So it might be, there's a resistor that's fed off of this, R15, 146 volts. Well, let's see the other side of this one here at 145. Now this is the same resistor over here. Let's just take a look at what we got here. Got 14 volts. So we're missing a voltage getting to this tube. There's where our fault is. We have an open resistor or something that's causing loss of power to the tube itself. But since I've got two channels identical, I can pretty much compare from one to the other. So the feed, this is through a 100K resistor right there, 151 volts. But you see on this one here, I gotta watch this thing out here. Only at 14. So here's where our fault is. We've lost the voltage. So it's just a matter of finding out where we've lost that voltage, and that should be able to get this amplifier up and running. Before I go any further, I'm going to just redo some of these connections, because you see when I look at connections like this down here, that doesn't look very good on this tube socket. So we could have a connection that's throwing everything out of balance. So I'm just going to redo these connections, and then we'll check the voltages again. I see huge discrepancies between the right channel and the left channel on some of the tube sockets. I've checked the resistors in the neighborhood and they're all measuring correct. But we could have a connection problem that's causing this. This is a double-sided board, so there are connections through on the other side. But you see some of these ones here look like, they look like crap. Like this one over here doesn't look like it's even soldered. So I'm just going to go through and just touch up the board. And then we'll do some more measurements. See whether I've made any changes. Customer said that it hummed initially. The one channel, you could hear like a hiss or a hum coming out of it, and then it went dead. So you got to think that something went bad. Either a component failed, or we've got a connection problem. And when I see stuff that looks like this, it makes me kind of wonder that maybe we might be looking at a connection problem. So we're going to address that first. So the power is completely drained off this unit. I've checked the high voltage caps with the meter, and we're sitting down at less than 1 volt, so the unit is safe to work on. I wish I could find a schematic for this unit, but I've looked at the usual sites and there is nothing. I can find the owner's manual for it, and that is it. So I've kind of drawn out a schematic to show me which is which for the tubes. I don't have a schematic for it, so I'm kind of working on my own. This is part of being an engineer. It's being able to look at the circuit and reverse it without knowing what's what. I wonder if I've got a bad cap. One of these caps could certainly cause that problem, because the bias to the tube is way off. So one of these caps here could cause it. Let's just take a measurement and see if there's any shorts on any of them. Might even get a chance to use my capacitor checker. Wouldn't that be neat? I've got a Heathkit capacitor checker I've never used. But let me just check some caps here. So let's just check this one. See, we're looking to see if there's any resistance between them. That one looks to be no shorts there. Remember, this side's okay, so we're just going to check this other side here. Let's just check this one here and see what we get on this one. Oh, 1.1 ohm. That looks a little bit low, doesn't it? This is a 0.1 at 250 volts. I wonder if I can pull this out without pulling the board out. We'll just heat this thing up. Get these out of the way. See if I can get this one to pull out without heating up without removing the board. Okay, now I've removed it from the circuit. I just want to check it out of the circuit. One leg disconnected, and it is indeed shorted. Haha! There's our fault. Got a shorted cap. It's a 0.1 microfarad. 250 volts. I probably have one of those kicking around from my days of servicing tube radios. Out of circuit. .1 ohms. It's shot. Let's find another one. 0.1 250. I should have one of those. Alright, now when I power the unit up, I should get the correct voltage onto the preamp tube, and then we'll throw it together. I can probably just throw the bottom on it at this point and plug the tubes in and test it, because it should be good. We'll check the voltage first before I go to that trouble. So, power on. Let's just see what my voltage is. Return to normal. So pin number 1, our voltage is now coming up. It was at 14 volts before, and here we go. Our voltage is now correct. Okay, let's power the unit up and see if we get any sound. Power on. The sound start playing, and when the amplifier warms up, we should get sound out of both speakers, which we do. Okay, so that has got both channels working now. That makes me happy. I got to deal with this switch here, because the switch, the bias setting switch is dirty, and one of the reasons I didn't remove the circuit board was because a lot of the wires are too short. I'd have to disconnect a bunch of wires to do it, and that's the same reason I don't want to remove the board to try to clean this control, because the wires that connect the output tubes, for example, are pretty short, and I have to remove several of them just to do it. So big job to get the board out. And that's why a lot of the components are soldered on the bottom, so that they can be just changed the way that that one was changed without having to pull the board out. They put the components on the trace side, on the bottom side of the board. I'm going to take this knob off. It's held in place with a set screw, and see if I can get some cleaner into the switch. Unfortunately, the smallest Allen key I have is a 1/16 and a 1.5 millimeter, and that's a little bit too big for this, so I'm not going to be able to remove the knob, and that's another reason I couldn't remove the circuit board, is because the knob has to come off to do that. So I don't know if I'm going to be able to get any cleaner into the switch. I might be able to get some cleaner into the switch if I go in here beside the yeah, I can probably get some cleaner into the switch by the tube socket here, because I can see the switch right here. I don't know if I'm going to get any cleaner into it or not, but I'll certainly try from in through here. See if I can get that switch to clean up a bit. Get in there with the neutral and spray it down a bit and see if I can get that switch to stop acting like it's got dirt in it. So what the switch is for is just to switch the meter to the different tubes for setting up the bias. So to do that, we kill the sound. Ideally, we want around 40 milliamps of idle current through each of them. That switch was pretty bad before. As you can see, it's a lot better now. It's not jumping around. That's off. So it's not jumping around. A little bit still. Oh, see, it's the switch. So he's worried about that, thinking his amplifier is going out of bias, but it's actually not. It's actually just a switch. So a little bit of cleaner in there. Hopefully that will keep that switch in okay shape. It's not like you have to check this every day anyway. Let's see. Yeah, so the switch is just a little bit, as you can see, if I wiggle the switch around, the meter moves a bit, but it's really not that bad. Once the bias is set, you generally don't have to play around with it much anyway. Once you've got them set up. But that switch, as you can see, is maybe I'll try resoldering it. The switch itself is giving me some trouble, but it's not going to affect the operation of the unit itself. It's just the contacts in the switch. I'm going to resolder the other tube socket as well, because just looking at the tubes themselves, you'll see what I mean. I'll show you a close-up of it in a minute. They all look like they're ready to fail. We look over here, you'll see what I mean. Check these out, see? We even have the secondary lights on here, but some of these connections here don't look to be too good. So I'm going to redo these ones while I've got it apart before I put the bottom off it. But so say that to take the board out to do any work on the top side, first of all you got to remove that knob, but I got to take out, I got to disconnect all the wires that are, well, most of these plug in, the filaments don't. The power transformer and the output going to the plates, or to the screens, as you say, plug in, right? The two sockets for the screens, these will unplug. Like these ones will unplug, but the filaments need to be unsoldered because they're just not long enough to swing the board up. And this will unplug as well. But I gotta pull the knob off to do it, and I don't have an Allen key that will fit it. So we work this way. I resolder the tube socket on this side. And tube sockets, sometimes the connection's cracked because people swap tubes, right? when you're removing the tubes to change them, you're wiggling the sockets and it can cause the connections on the board to crack. So we'll just do these and then put the bottom of it. We'll just resolder these ones. I'll put the bottom on it and test the unit and give the owner a call and let him know his little pride and joy is putting out sound on both channels again. I don't know what he paid for this thing, but I would imagine he probably paid $1,200 or $1,400 for it, because that's what typically these things go for on the used market. They're not cheap. But anytime you get into tubes, you're spending money. I know my little Yachin that I've got, which is almost identical to this thing, minus the bias meter. I have to set mine up with the multimeter. But circuitry wise, it's going to be pretty darn close to this, because all tube amps are pretty much the same inside. When I bought it 10 years ago, I paid about $600 for it, because it was a startup company. But now I've seen my little amplifier that I have on the used market going for like $1,100–1,200 on the used market. Even though you can buy a new one for that kind of money. Okay, I'll put the bottom on this one. We'll throw the tubes back in it. Give it a final test. Just gonna put my zap tie around here to zip those wires together like they were from the factory. You notice that when I serviced this unit, at no time was there anything sitting on the resting on the capacitors. All the weight was on the transformer, and I had a cardboard box under the front to support it, so that nothing was touched. And the tubes, when you're handling vacuum tubes, don't touch the glass, or use a cloth or gloves or something. Always try to handle them by the base, just because oil from your skin can degrade the glass. It can mark the glass, but it can also degrade it. So if you touch them, it's not a bad idea to wipe them off, or try to handle the tubes from the socket like that. Keep your fingers off the actual glass. I don't know whether it hurts it or not, but that's what they claim. They claim you should always keep your fingers off the glass if possible. Okay, one last test. We'll turn this thing on. Look at that, it makes my lights dim. This thing draws so much power when it starts up. Charge up these big filters. And when it warms up, we should have sound. Well, I guess I should start the sound playing. Well, I've had it running now for a few minutes. Thing's sounding great. Turn off the heat in here because I'm pretty much done in here for the day. Today, little cooler day today. Had to actually put the heat on in here. For the end of February, we were having a bit of a cold snap. Switch is, as you can see, the switch itself is this is not critical. I mean, once your bias is set, you normally put it in the off position anyway, because you don't really need to have what the bias switch does is it bypasses. There's a cathode ground resistor that goes to ground off of each tube, and what the ammeter does is it goes in series with that to measure the current. When I test mine, like I measure across the resistor to measure the voltage drop across the resistor. This goes in series with it to measure the current flow. So normally you get it in the off position, otherwise you're passing your current through the meter. But it seems to be pretty stable. It's just the switch itself. If we look at the bias controls, they're all, they're sitting almost in the same position if we look at them here. So we know the bias is approximately the same for each of the tubes. You turn it by hand here, or a screwdriver. You turn it with your finger. But when you test the bias on any amplifier, any tube amp, you've got to do it with no sound. So how we do it is we set each one to 40 millivolts, or sorry, 40 milliamps for the 4 tubes. Once the unit's been warmed up for a while, you don't do this until your amplifier's been sitting idle for several minutes, because the tubes need to stabilize, and then you would adjust them all. And I've done this, I've shown this on my Yachin. Once you're set up, once you're running it at operating temperature, you want to set your bias to around 40 milliamps DC, or what's mine? I think mine's a 0.2 volt drop. I have to go look at mine. But once you've got it all balanced and set, then you're good. And how you can tell when your tubes are getting near the end of their life is, of course, when you check it. Oh, look at that! Just static electricity causing it to move. Looks like the meter's not even centered. Might help if the meter was zeroed out. Okay. Static electricity. I got magnetic fingers. The meter's sticking a bit too. That might be part of the problem. The meter's sticking. Oh well. We're pretty close. Pretty close. Good enough. Damn. You know, it even makes MP3s sound good. I tell you, once you hear a vacuum tube amplifier, you really don't want to go back to listening to anything else. For, you know, for moderate listening, obviously you're not going to shake the walls with 35 watts per channel, but my God, this thing sounds good. Alright, I guess I'm going to wind this one up now. We're pretty much done on this. I'll leave it running here while I'm testing it, but we're all done. We'll catch you in the next one. Thanks for watching.